Hi everyone, how are you my dear children? Hope you all are safe and healthy. In my last lecture, we have discussed about the buoyant force, what are the causes, okay, rather the factors affecting the buoyant force we have discussed. And even we have discussed the relationship between the buoyant force and weight of the liquid displaced, that is your Archimedes principle. And towards the video lecture, last part of video lecture, I have given the mathematical proof what is not there in 9th class book. And in that proof, I have again discussed the two factors, how it is dependent on the density of the fluid it is, if the object is immersed, and what are the volume of the object, how it is related. That also we have seen in that mathematical proof. And again what we have seen, this proof of Archimedes principle. Okay children, so today we are going to discuss this Archimedes principle and specially the application of this Archimedes principle. Okay, so mathematical thing we have discussed, and I have explained also what this principle is conveying us. Okay, so let us see what is Archimedes principle. This is applicable in the case of fluids, children. Fluid means it holds good for liquids also and it holds good for gases also. So what is the exact statement you will get in your book? That is, when an object is fully or partially, fully means completely immersed in your fluid, it experiences a buoyant force. Buoyant force is your upthrust, children. Then that buoyant force is equal to the weight of the liquid displaced by the object. So buoyant force acting on your object is equal to weight of the fluid displaced. Weight of the fluid displaced by your object. Displaced by object. And when the object is having mass, it will be mg. I have already proved it in my last lecture. Those who have not seen this proof, please go through the last video lecture. And this will be the buoyant force or upthrust acting on object. This is your Archimedes principle. Okay? This thing we have proved it using liquid. Any liquid you can take. And same also, even gases exerts an upward force or the buoyant force on the object placed in them. Okay, so that's why we are using fluid in the statement. Don't write liquid, children. It is there in book also. Liquid is also there, even fluid also there. So my suggestion is you write, please write fluid. Clear, children? So no more extra explanation is required. I am not going to make you bore with this again telling the proof. Please go through the last lecture. Okay? Okay. Now we'll see the application of this Archimedes principle. So many applications are already there actually, but I am going to discuss only one today. Application of where you will see this Archimedes principle. In day-to-day life we have discussed so many. Suppose you are taking bath in your bathroom and you just completely fill the bucket. Then try to immerse your mug. So when you are immersing in the full, up to the rim, the bucket is full with water. So when you will immerse your mug inside your bucket, then you will see some water will splash out, because that mug has to make its place. So that amount of water has to be out of the bucket so that mug can आराम से sit inside the bucket. So these are small examples. But what are the big examples? You will also study in higher class how the lactometer is it is a instrument to check the purity of milk. So this lactometer is based on your Archimedes principle, children. Even the hydrometer is based on your Archimedes principle. What is this hydrometer? This instrument is used to measure or determine the density of the liquid. Okay, and we'll see also this Archimedes principle is helpful to find out the relative density. Okay, so many examples. One is lactometer, second is hydrometer, lactometer to determine the purity of milk. Then hydrometer, hydro means water. Okay, something related to liquid, hydro. Okay, not necessarily water, it has to be liquid. So hydrometer is used to measure the density of liquid. And third, to find the relative density. We'll see what is this relative density in subsequent lecture. Okay, and fourth one, we have already seen this fourth one. You can visualize this fourth one, you can relate now. That's why I am going to explain the fourth one, because you can visualize, so you can feel this application and it will help you to understand Archimedes principle in better way, or you can say easier way. This Archimedes principle is used in designing ships and submarines. Ships and submarines. Okay? Clear? These are small applications. So let us now try to find out how the Archimedes principle is applied in the case of ship and submarine. See children, I think everybody has seen ship. So here there will be water and here you will see ship. Okay, so this is your ship. And very surprising or funny thing is that ship is very heavy, very huge. Okay, and this ship floats in water while you take a small metal block. You can say this metal block is iron block. When you will try to immerse this block, easily it will sink. This small iron block will sink, but huge ship is floating. Okay, this is floating and this is what? This is sinking. See, from this easily we can now make out it is not related to your weight. This is heavy, this is not heavy. If you compare the weight of the ship, definitely more than your small iron block. Okay, so if it is light, it will float. If it is heavy, it is going to sink. This theory is not applicable, children. Then what is applicable? It depends on density rather than weight. Okay, children. Actually, this ship is not a solid. This ship is not a solid block of iron and steel. Rather, ship is made in such a way that this is inside. It is a hollow. It is a hollow object. Hollow means lot of empty spaces are there. The shape is like that. It is hollow inside. So that means lots of air is there. Clear, children? Empty spaces means air will be there. And we know the density of air. The density of air is less than density of water. Okay, the density of air is less than your density of water. So it will float. It is a lighter thing now when you compare to the density, not weight. Please carefully try to understand. Please focus. In the case of small iron block, it is completely packed, children. Everywhere there is iron material. And we know the density of iron is much greater than density of your water. That's why it is sinking and it is floating. This is one of the point. Clear? This is the first reason why ship is floating and why this small iron block is sinking. Clear, children? Now let us discuss what is the second one. Very important for question actually. For exam purpose, it is also very important. See, those who don't know physics, they will be surprised why this ship is floating, this huge ship is floating and small nail is sinking. Small iron nail, small metal block is sinking inside the water. But how blessed you people are. Since you are studying physics, you can understand this and you know the reason, so you are more smarter. Okay. Now what is the second point, children? Second point is, we have already discussed about the water displace. When ship will displace, when ship you are trying to, this is your water and this is your ship. This part is get immersed in your water. Okay. And this heavy ship floats. Why? Because it displaces large weight of water. So large weight of water means it will give a greater buoyant force. Archimedes Principle. See, this ship will displace some water and that displaced water is equal to your buoyant force. And here buoyant force is more because it displaces large amount of water. Since buoyant force is more, of thrust is more, the ship is floating. Clear, children, why ship is floating? Two reasons we have discussed. Okay, so when ship is placed in water, actually see, certain level only dipped inside the, immersed in the water. Certain level only sinks inside the water. And this sinks means this part displaces water and that weight is equal to your buoyant force. And since it is a heavy amount, so buoyant force is also more. That's why it is helping your ship to float. Hope I am clear with this. With the same concept, based on the same concept, submerged, children. How submarine works? See, you people might think the ship is floating, but submarine is sinking inside the water. Then how it is the same principle? This is your submarine. In case of ship, what we have seen, there is lots of hollow space. Hollow means air is there and density of air is lighter than your liquid. In case of submarines, there is an arrangement inside the submarines. There will be a tank. Inside that tank, we can say a buoyancy tank. Inside that buoyancy tank, there will be water. Water is filled inside your buoyancy tank. That's why it is sinking inside the water. It is sinking. So when submarine will do its job, whatever, while the submarine is there, to do some certain work. So after, that's why it is inside the water. Nobody can see. So after doing its work, then submarine has to come up. So how it will come up? Because it is filled with water. So it can't come up, it can't fold. It can float. So what we will do? We will remove the water from the tank. method is there. I am not going to into the details of that method. So what? Simply just think, water is filled inside the tank and it is sinking. Now we have to come up. Then we will just remove the water from that tank. Then submarine will come up. Okay, it will float on water. That means what we are doing? Think, analyze, research. Okay, I am not going into the detail because it will be too much for you people. Hope I am clear with this Archimedes principle and how Archimedes principle is applied in case of ships and submarines. In higher class you will see all the lactometer, hydrometer, relative density, how it is helpful in finding the relative density also. In this class also we will see that. So Archimedes principle is done over. So next lecture we are going to see why the objects float or sink in a liquid. Now you people have the fair idea how object is sinking and how object is floating. So next lecture is going to be easy for you. But here a simple but. This theoretically we have already discussed these things. We know the reasons how it sinks and how it floats. I am going to show it mathematical, children. So you can feel it in better way. You can realize it. You can relate it. So in my next lecture it is going to be again beyond your 9th syllabus. I am touching again 11th syllabus here. Why I am touching so? Because I am thinking you people are smart, you are interested in physics. So if I am giving this little bit extra mathematical proof or certain concept extra, then it will make your subject or chapter interesting and easy for you. And those who are interested for higher thing, those who want to pursue science after 10th, it will be really help them to understand or deal with 11th class physics in better way. And obviously for entrance. Because if you are tired of this much of physics in 9th, just think 5 times it will increase the syllabus. In 11th you will see the mammoth syllabus in 11th and 12th. So be prepared, tighten your seatbelt and work towards this. Hope you have understood this lecture. This is an easier one. I am waiting for my next lecture so that I am eager rather, so that I can provide you more. That actually makes me happy. Hope you people also find same. Hope you people also feel happy while viewing this video lecture. Thank you for watching. If any doubt, leave a comment, children. I will be happy to address your doubts. Okay? Thank you for watching.